So let's start with the sizing. So you right click on the mesh, and now instead of creating generate mesh, first we will clear the mesh because we are not satisfied with the current mesh. Okay, clear the mesh. Now it brings me back to my normal geometry, and now I go to mesh and I say insert mesh method. So there are different ways of meshing your own geometry holistically, but let's look at the one which is the most easiest one, or the one to start off with. So let's start with method. It will ask you to first select geometry. So I would click on my geometry, and now there are multiple ways of selecting geometry as well. Now here in this case, since we have two geometries and I want to select both, so one way of doing that is moving to my toggle bar which says select mode, and then it asks you whether you want to select one body or you want to do a box select. A box select means everything in that box would be selected. So if I go on box select, and if I draw a box around my geometry and then click it, now it has selected both the bodies, my enclosure and my geometry inside it, which is a circle, and then I click apply. So it says here selected two bodies. So that's good because I wanted to select both. Now it asks me for which method I want to use. Automatic means the CFD will use the method that it thinks is the best, which is what we saw a few minutes back. I can however change that. I can say that I want my mesh to be only tetrahedrons, triangles, or I want my mesh only to be hexahedron, which is square. So if I go by hex dominant and see how it works, so I've selected hex dominant here because I want a hexa mesh, and then I do the same thing again, mesh, and then I click on generate. Now this will generate the mesh. Allow access. Sorry, we don't want this one. So back to our normal screen, and what we see here now is a completely different mesh to what we saw earlier. Earlier we saw a tetrahedron mesh which was mainly triangles, but what we see now here is a hexahedron mesh, which means it's squares. Now generally squares are more accurate. Squares give you a better node to element ratio, and it is considered to be more standard. However, you would still see here that in the circle the CFD is not able to, or the Ansys mesh model is unable to create a hexa mesh around the circle because it is a circle. So what it has done, it has created an unstructured hexa mesh. So what we see on the outskirts is a structured hexa mesh, and what we see inside the circle is an unstructured hexa mesh. Again, it has listened to our requirements of making it hex dominant, but in parts where it is unable to do a proper hexahedral, it has done an unstructured hexahedron mesh. So let's see what this brings us in terms of our statistics. Very different. If you remember, or if you recall, in our tetrahedron mesh we had about 2000 nodes, but we had about 14,000 elements. But what we see here now is still about 2000 nodes, but only 2000 elements, which means that the element to node or node to element ratio is more one-to-one here rather than in terms of tetrahedron mesh, which is why this mesh is more considered more accurate in the area of research. But then again, that does not mean that the tetrahedron mesh is wrong, or it doesn't mean that the tetrahedron mesh will give you inaccurate results. It is still a good mesh to be used. It just depends on your preferences. But the challenge that we are still left with is the element size is too big, because if I still go on sizing, if I see my default element, it is still about 7 meters, which is very similar to my tetrahedron mesh. So this is one of the major reasons why I have to refine my mesh to make the element sizes much more smaller. And that is what I'm going to do now. So we have first moved away from a tetrahedron to a more structured hexahedron, and now we want to make it more accurate. So what I will suggest now to the mesh is to make it more accurate, which means insert, and now we go to the second part, which is sizing. So first we selected the method, and now we select the sizing. And now it will ask us to again select geometry. We would do a box select, click a box around it, click apply. So my geometry is selected, and now it will ask me for an element size, which I can now specify. So if I thought that the element size of 7 was too big, which it is, so I will now make it much more finer, and I will say I want my default element size to be 1 and not 7, and then I click on enter. So now I am giving a command to the CFD and saying that I want my element size to be 1 meter rather than 7 meters. Again, I go back to my mesh. As we can see, lightning arrow. I need to then now generate the mesh, and let's see what difference this makes. So I have given it a command to make my mesh more finer. As you can see, it's taking time because now my element size is much smaller, which means I will get a lot more nodes and elements, and as a result of that, my time taken to create a mesh is much longer than what it was before. If you were to decrease the element size further, it will take more time. It will improve accuracy, but it will take more time. So it really depends on the compromise that you are looking for between computational time and between the accuracy of that model. Nonetheless, this is working now, and you can still see it's taking quite a lot of time. 80%, 70%. The good thing about the good feature about this mesh here is now we can see a lot more statistics than we used to see maybe about 10 years ago. Ansys have really upped their game in the last decade, and it is much more user-friendly now. We can see much more statistics, and they generally are able to see a lot more information. Just want you to keep focusing on the element size that will be generated by the new mesh. So we still see meshing going on, and frankly speaking, I did not expect it will take this much time. Considering the element size of 1 meter is still quite big. When we are looking at research and academia, we are working with element sizes of 0.01 or 0.001 to that level of accuracy. But you have to keep in mind that the geometry is about 100 meters in this case, which is 100 meters of real life examples. So normally when we are working in research, we are not working with the geometry of 100 meters usually, because we like to take it in small elements and we like to take it in small parts, not generally this huge. But since this is done for just education purposes, I would like to clearly show you the difference between the default mesh, difference between the tetrahedron and hexahedron mesh, and what difference an element size can make when it is changed from its default to now a user-defined source. Bear in mind the original element size was about 7 meters, and the new element size now is 1 meter. So that is 7 times much more finer than what we had when the Ansys CFD was generating its own mesh. So this must have taken a good 3 minutes, close to 3 minutes now, by generating the mesh. So you can get some idea that if you are working with a complex geometry and you are working with a complex mesh, your meshing time could take about an hour as well. And meshing is very important for your CFD application, because meshing is the heart of your solver. without a good mesh, your geometry will not be discretized or will not be broken into the required levels used for solving the model. So it is important that the mesh is correct, and it is important that the geometry is meshed, because if it is not meshed, then it will not work. Right, so while we are still meshing, and this is something that has just occurred to me, that the meshing can take a lot of time. I'm glad that it has not failed. So if it would fail, it would highlight the geometry in yellow to say that the meshing has failed. But it appears to be that the mesh is obsolete, but the mesh has not failed, which means that the mesh will be generated. You have to remember that we gave it a command of hexahedron mesh rather than tetrahedron. So therefore the meshing time will be taking into account that we are forcing our geometry to be meshed using squares rather than to be meshed using triangles. Triangles are more easier to mesh. Squares are more difficult to mesh. And squares which are 1 meter in its length compared to 7 meters would take 7 times more the amount of time. So if our previous mesh was carried out within 30 seconds, you would expect a time of about 4 to 5 minutes for this new mesh to be generated. As we can see here, converting triangles to quads. Quads are technically squares, quadrilateral, hexahedral, technically relating to a square. So while it is converting triangles to a quadrilateral, that is where it is taking a lot of time to be meshing. So thank you for waiting with me. I'm still on the video. I am waiting for the mesh to be generated as well. I can easily stop this now and go back to the default mesh and then just get over with it quickly, but I really want the users to know the impact that each time when we say more accuracy is better, but more accuracy means more computational time and more runtime, and time is money, and it is important that you balance the accuracy of your work with the time, because as I've said before, if you are looking only to prove a concept, or if you are only looking to get a general picture of how fluid flow happens around objects, then we don't really need that accuracy, because the Ansys default mesh is capable enough to give you good results and capable enough to give you accurate results.